Hello everyone, welcome back to our series How to in my class CSE 120. Today we're going to learn about universal gates and the LogiSim circuit analysis tool. So in this video I'm going to show you how to convert from a given Boolean equation into an NAND circuit and how to use the analysis tool and LogiSim evaluation to prove that the equation are equivalent or they are the same. The design task is to use only NAND gates to build a circuit given its output function like the one shown below. We're gonna go back for this function in the later part of this video. So the first thing I'll talk about are the universal gates. Universal gates are NAND and NOR gates. They are universal because they can be used to produce any of the other logic function. For a NAND gate, you can use one NAND and one NOT to make an AND, or two NOT and then a NAND to make an OR gate. The similar things go for the NOR gate. You can use a NOR gate with a NOT to make an OR, or two NOT with one NOR to make an AND. So what about the NOT gate? When physically wiring, a NOT gate can be replaced with either an AND or a NOR by connecting one input into both input ports. Each of the following images show you how to produce X NOT. The first one is just a simple NOT gate, so X is inversed and you have X NOT. The second one uses an AND gate, and the third one uses a NOR gate. For the second one, you have X times X and then all inversed, so you still have X naught. The similar thing goes for the third one, but when drawing a logic circuit, this is more advantage to leave the NOT gate drawn in a NOT gate because it is a lot easier to understand and interpret the circuits. For example, in the circuits on the left side, you see a NOT gate is way more understandable than the one on the right side. So even in our NAND circuit, we still draw the NOT gate. The next thing I want to talk about is the steps to design an NAND circuit. First things first, you have to draw a circuit using any combination of AND or NOT from the output function. Next, you have to use the key from last slide, the one that show you how to make an AND or an OR gate with a NAND or a NOR gate to replace those AND and OR with NAND equivalent. And the last thing is to reduce or simplify the circuits by cancelling out the double NOT, because when you inverse an inversion, you get just the initial value, so you have to cancel the circuits, the wires that have double NOTs in it. So let's talk about our design test today one more time. We have to use all NAND gates to build a circuit given its output function like the one shown below here. Okay, so let's move on to LogiSim evaluation. The first step in making an all NAND gate circuit is to design a circuit using only AND, OR, and NOT gates. This is a completed circuit beyond the function Q right here. I have labeled the output of each gate to let you understand how I get the final output Q. The next step to design an NAND circuit is to replace the OR gates and the AND gates with the NAND equivalent. I'll show you in the next sub-circuit right here, the all NAND process. So we have two circuits in this area. The first one is just a copy of the original circuit, with only AND or NOT gates. So the next thing we have to do is to replace these with the NAND equivalent. I have these two small circuits right here. They're not circuits actually, just a NAND equivalent of an OR and an AND. So what I have to do is to delete the OR right here and shorten the wire to make some space for the NAND equivalent, I guess. And then I just have to copy this example and replace it with the OR gates and then connect the wire. That's for the AND gate, right? The OR gate right here. I still have one more AND gate that I haven't changed yet. So let's do that together. Delete the AND gate. Alright. Shorten the wire a little bit to make some space. Copy the NAND equivalent of the AND gate. And let me shorten this wire also. Make some space for the AND gate. Drag and drop the NAND equivalent into place. And connect the wire. And you keep doing the same things for all the OR gates and the AND gate in the circuit. And you have the OR NAND circuit right here. I have changed the OR gate right here and right here to the NAND equivalent. And that's it. We have the NAND circuit based on the function Q. You can prove the output Q1 of the circuit is actually the same with the output Q mathematically, but it's quite troublesome. I'll show you how to use the analysis tool and LogiSim evaluation to prove that in the later part of this video. But we haven't done with the OR NAND circuit yet, because as you can see that on some wires we can see the double knot are still there, because the inversion of another inversion is just the initial value. So we have to remove this knot because they are redundant, they are not necessary. So what we have to do is just delete these two NOT gates, for example, and connect the wire. That's what I did for the third gate right here, the third circuit. I'm sorry. You can see that in this wire we have two NOT gates. I remove them and just connect the wire straight to the next gate. The same thing goes for this wire. It have two knots. You have to be careful to examine each wire to detect the double knots. And then the final thing is to remove the double knot on this wire, and we'll have this. So I think that's it. We already removed all the knot, the double knot, and we have the simplified version of our non-NAND circuit. That's it. That is how the process goes. But how can we assure that the output functions are the same? We're gonna use the LogiSim function, LogiSim tools to prove that. I'll show you now. So I have copied the simplified version of the OR NAND circuit in the OR NAND process circuit and make another subcircuit right here with the name OR NAND simplify. We're gonna use the analysis tool and LogiSim evaluation to prove that the output function Q of this simplified circuit is actually the same with the initial circuit. So you should click Project, Analyze Circuits, It will show you that the expression is not determined yet, and we can build based on the truth table generated from the circuit. Just click OK, and you see a truth table that was generated from this circuit. When you hit the expression, you see the minimized version of the output function. So we have B naught plus A times C. So this is the simplest version of our output function. So if we want to prove that this one is the same with the original one, we also do the same thing with that. Just double click in that. You can also right click on the sub-circuit, and you also see the option to analyze the circuits right here. Click on it. It will show you the same message for that because the expression is not written yet. So click OK. And you also see a truth table. You can compare the two truth tables with each other to make sure that the output are the same. But you can also click on the expression, and you can see that the output for this, please look at this one, actually Q capitalized. The Q, the big Q right here, is equal to B naught plus A times C. So the two circuits have the same output function. That is how you can use the tool provided by LogiSim Evolution to analyze the circuits to prove that the simplified version of the NAND circuit are the same, or it produced the same output with the original one from our output function. Besides analyzing completed circuits, LogiSim also provides you the tool to build the circuits from scratch based on the output function. I'll show you how to design a circuit, an AND/OR circuit, from the simplified output function we have just now, which is Q equal to B naught plus A times C in this empty subcircuit. You click on Project, Analyze Circuits, or right click and then Analyze Circuits. They're the same. Click on it. The input variables and the output variable are not declared yet, so we have to enter those input. We have 3 input: A, hit enter. Do the same for B and C. And we have 1 output, Q. You have 2 options. You can either fill the truth table, or you can enter the expression in the expression tab. As you can see here, the output Q is not specified yet. Double click on it. You can enter B naught by enter this sign right here. You can get this sign by press shift and the key next to the number 1. So B naught plus A times C naught, and hit enter. Please be careful because this is actually not the output function that we wanted. So what you want to do is to make sure that the order is correctly. So you have to enter the parentheses that we have B naught plus A times C naught. And then hit enter. So we have the output function Q equal to B naught plus A times C. And then you can build the circuits by clicking this button right here. Click on it. And it asks you how you want to draw the circuits. You can either draw 2 input gates only, it is AND and or you can use the OR NAND gates only. So we are trying to make an OR circuit. So click the checkbox right here and click OK to replace our circuit in OR simplify. Click OK. It will ask you if you are sure to replace the circuit. Yes, I'm sure. Click yes, and that's it. You have the AND OR circuit designed by LogiSim Evolution based on the output function. Alright, that's it for today. Thank you for watching and have a good day.